Okay, now look at the lines here. Are they linear or non-linear? So our topic for today is linear functions. Okay, lines. Okay, there are characteristics of a line written in a graph. First of all, let's contrast between linear and non-linear. Okay, I have two examples here. Look at this orange line on the first graph and look at the orange line on the second graph. Obviously, just by looking, which is a line, obviously the left side is the line. So let's write the word linear. Okay, let me write the word linear here. Linear. And the other one, it's not a straight line, right? Not a straight line. It's a curved. So write the word nonlinear. Nonlinear. All right. So math teachers go beyond looking or beyond the visual. They have numbers. Okay. They need numbers to prove that they are linear. And what do? They look at the rate of change. New vocabulary, rate of change. How would you know the rate of change? You're comparing the change on the y over the change on the x. What do you mean by that? Check this out. So if you look at this, let me highlight it for you. All right, if you look at this, it goes up by 4 because it's 2, 4, 6, rather 6 goes up by 6, and to the left 2. 6 over negative 2 is a negative 3. Okay, we know that. But you could also see another pattern here. It goes up again by 2, 4, 6, and then 1 to the right. See, all those points, all these points will always have a pattern. You call that the rate of change, which is always negative 3. Negative 3. Okay, if you do that again, look, let me do that. 2, 4, 6 to the left, that's another point there. I will always have that negative 3. That negative 3 is called the rate of change. Negative 3 is constant. Constant or consistent. It will never change. Okay, but check out a curved line. So here it goes up by 2, 4. You have the 4, and then 2 on the left going there. 4 over 2 is a 2. So the rate of change here is 2. But if you look from one point to another point, it goes up 2, 4, 6, 8, 10, 12 over 2. 12 over 2 is a 6. Compare your 6. Compare your 6 and your 2. Are they the same? No. And it will always change. Sometimes at some portion, it could be a 12. It could be a 7, 18. They could change. The rate of change could be different all the time. So therefore, you could say it is what? It is not constant. But this is constant. Now, for today's lesson, our focus will be linear. Linear, and we'll be talking about the rate of change, and we will be talking about another vocabulary called initial value. But the best way to distinguish a linear and nonlinear is just by looking at the line, okay? It is a straight line. You could put a ruler on top of it, okay? It won't go outside the ruler. This doesn't follow a straight edge because there are curves. So visually you could identify it. But you could distinguish this. But if it starts at 0, we learned this before. If it starts at 0, it is what type of line? It is proportion. Okay, but today we're not only talking about proportional lines. Okay, we will be talking about lines that doesn't start with 0. It could start there, it could start there, it could start anywhere. All right, so remember, we'll be talking, our focus for today would be the linear. Okay, two important terms that you should remember between um, linear equations in real life. So initial value and rate of change. Okay, definition. Initial value is the y-intercept. It is the output value when the input of linear function is 0, related to 0. Okay, it is the value of y when x is 0. It is the y value of the point where the line crosses the y-axis. So take note, important points is 0. That one, 0. Important points is the value of y. Those are the two things you should remember. Now, rate of change is similar to what we did a while ago. Okay, it is the output over the input. It is the ratio of y over the x. We were looking at how much did it go up, the change in the y, and how much change happened on the x-axis. Okay, remember those two important vocabularies because we will see how it applies in different situations. Okay, one application is gym membership. Okay, probably you know this, or your siblings, or your friends, your uncles, they enroll to a gym, and in the gym, you have to pay a membership fee of 100 bucks and a monthly fee of $40. Now, that membership fee of $100, since you have to pay that immediately, whether you're going to attend the monthly session or not, you'll have to pay the 100. That is called the initial value. I repeat, initial value is the first amount you'll have to pay at, you could say, at month zero. You haven't started. That's the initial thing you need to pay. Next, and every month you'll have to pay the $40. This $40 is now called the rate of change. Okay, because every month it's always $40. It's not 30, it's not 50, it's 40. So you saw that in a worded problem, you could easily identify those two. Now we're going to organize the gym membership information using two graphs, right? This is a horizontal graph while this is a vertical graph. Okay, so let's start with this first. You would see that for every month it goes up by plus 1, right? 2 became a 3 plus 1, 3 became a 4 plus 1, 4 became a 5 plus 1. So the pattern is consistent. Going up by months, goes up plus 40, plus 40, okay, plus 40, right? 220 became 260 plus 40, 260 became 300 plus 40. So we're consistent with the pattern. And usually you make a ratio out of it. How do you make a ratio out of it? You make it $40, money is on top, over 1 month. Okay? 40 per month. That's your unit rate. And that is also called the rate of change. Okay? Rate of change. Now, let's see if it also works on the other graph. Let's look at the pattern on the other graph. Goes up by plus 1. Yes. Plus 1. Everything is plus 1. 4 to 5 plus 1. Okay. Now, 100 to 140 is plus 40. Okay. Plus 40 again. 182 to 220 is plus 40. 220 to 260 is plus 40, and again it's plus 40. We make a ratio out of that, 40 over 1. Okay, now let's think of two vocabularies again. That 40 over 1, that 40 over 1, this one and that one is now called the rate of change. Okay, that's the change for every month. Now, look at the zero, the starting point. When x is equal to 0, when the input is 0, okay, and the result will be what? 100. Even though you haven't started anything, you haven't started a month of gym membership, that is now called your initial value. Okay, initial value. Initial value is the value of the output when the input is 0, and that is 100. Initial value is 100. Okay, so we're still using the same data, but now it's in a table form. Okay, this will now be translated into a table. So I'll start with month 0. Month 0, everybody look at month 0. Month 0, the initial payment is 100. Month 2, month 1, I am paying what? 140. So 140 will be here because each of the box is worth $20. 20, 20, 40. Okay, month 2 I am paying what? 180. 180 is over there. Check, check. Month 3, I am paying 220. 220 goes over there. All right. So now, again, the points can be connected. The points can be connected. All right. It has to be a straight line. There you go. It could even extend there. It will go up there, right? Okay. Now, guess what? The initial value in a graph would be where 0 starts. So can you see that amount going up? Let me circle that number. That is $100. See that? 0 and $100. Again, we will name that as our initial value. Value. Okay, how do I see now the rate of change in a table? Easy. Look at this. Everybody look. From here to here, left to right, it goes up. Two boxes, meaning two boxes means what? Two boxes means 20 and 20, that's a 40. 40 going up and one month to the right. Okay, is that always consistent? 20, 20, 40, 40 going up, and then 1 month to the right, 40 over 1. Same thing if you start with 100, 20, 40, 40 over 1. See that? So 40 over 1 is this is now called the rate of change. And it is consistent. It is always 40. How do we check? Look at this. Plus 40, plus 40, plus 40, plus 40. Consistent. Okay, got it? Now let's have some problems. Nate went to a trip and he used the table of values to repeatedly record the time he had been traveling and the distance from his starting point. Distance from his starting point. Okay. The function represented by the table of values is linear. It says it's a straight line. And the rate of change is already given. 50 miles per hour. Okay. Which of the statements is correct? Okay, let's start. Any pair of values for time and distance, it is possible for Nate to determine the initial value by repeatedly adding 50 if necessary. Keep on adding 50, you would see where he goes. With any pair of values, the time and distance, it is possible for Nate to determine the initial value by repeatedly subtracting 50. Okay? If you keep on adding 50, it goes up there. If you keep on subtracting 50, is it possible to know what the starting point is? Think about that. With any pair of values of time and value, it's possible for Nate to determine initial value by repeatedly multiplying. Will you keep on multiplying your 50 miles? 50 times 50 times 50 to go get the initial value? I don't think so. And will you keep on dividing it by 50? So if you want to start to go to get the initial value, you have to go down. Therefore, you need to subtract. So this is the correct answer, subtract. Okay? Then you will know what the initial value is. Another problem. Sung-hee is filling a sandbox with sand at the rate shown in the table below. So if you look at the table, it will give you a rate. We will identify what it is. Which statement must be true regarding the linear function that represents the situation? What did we say again? If you see that starting point of 0, this will give you a clue. That is the what? That's the initial value. All right. So, but we want to see the changes that happened. Okay, this went up by 1, went up by 1, went up by 1, plus 1, plus 1. Okay, we're consistent with this. How about this? 200 to 220, it went up by 20. This one went up by 20. This one went up by 20. This went up by 20 pounds. So how do I write that? Is it 1 over 20? Is that how you write it? No. Start with your Y value, your output value. The result was 20, meaning 20 pounds for every minute. Okay, 20 for every minute. Okay, let's check. The initial value must be 0 pounds. No, we could see the initial value is 200, not you. The initial value must be 20 pounds. No, it's not 20, it's 200. Okay, the rate of change must be 0 pounds per minute. How can it be 0? So there's no change. So, but the last one says the rate of change must be 20 pounds per minute. Can you see that? 20, 20, 20. So therefore, this is the correct answer, the last statement. Easy, right? Next, we'll look at the graph now. Wilson began watering his garden with watering a can that was completely full. It started with full, okay? There is a certain number of gallons of water, okay? A can is filled with water, okay? If the graph is going down, meaning water is being removed. The amount of water in the can Wilson was watering can be represented in a linear function and is shown in the graph below. Which statement is correct? Let's check. All right, so just by again looking at the graph, what do you call that? Starting from 0 on the x, look at it, 2.5. You already know that 2.5 is the what? Initial value. Okay, we remember that. That's the starting point at 0 on the x. Now, what is the rate of change? How much did it change? Okay, let's check. The amount of water originally in Wilson can was 0. No, that's not correct. The amount of water originally in Wilson can was 2.5. All right, they said it already. The original was 2.5. So that's the correct answer. All right. Okay, let's see if the others are correct. Wilson is watering his garden at the rate of 0 gallons per second. 0 gallons, if that's 0 gallons, so nothing happens. Water won't disappear. The Wilson is watering the garden at the rate of 2.5 gallons per second. Is it 2.5 gallons per second? Let's check. So, so this goes up by 1, by 1, by 1, by 1. Now, from 2.5, it became 2.3. 2.5 became a 2.3. Let's subtract that. Let's subtract that. It is a 0.2. So water is being removed or being used zero point 0.2, not 2.5. Okay, so definitely that's wrong. So this is correct. The table of values below represent a linear function and shows the height of a tree since it was planted. What was the height of the tree when it was transplanted, right? The initial height. When you plant a tree doesn't start at 0, okay? It starts at a certain height, okay? And then it grows, right? Okay, and then it grows bigger, okay? This is at year 0, year 1, year 2, okay? But it's not here. If you look at the table, the year is increasing by half a year, right? Increased by half a year, zero point 0.5 plus zero point 0.5 plus zero point 0.5 and plus zero point 0.5. Okay, it goes up by half a year. For every half a year, it goes up by what? 1, 1, 1, 1. Okay, so the last one, the recorded was 4.2. Let's start with 4.2. I mean 412. Okay, our objective is to know what was the initial height at what? At year 0. Okay, that is a fourth year. So since we're doing it by half a year, in 3.5 years, what was the height in 3 years, in 2.5 years, in the second year, we're just taking away the 0.5, right? Following the pattern here. Minus zero point 0.5 is 1.5, minus zero point 0.5 is 1, minus zero point 0.5 is 0.5, minus zero point 0.5 is 0. So this is what we want to know. At year 0, what was the height of the tree? Okay, now look at this. For every half a year, it goes up by 1. If we want to work backwards, do we subtract 1 or do we add 1? We subtract. Okay, 12 minus 1, you're an 11. You're at 10, meaning at year 3, the height is 10 feet. At year 2.5, the height is 9. We're just taking away 1. Remember that. We're removing 1. Okay, minus 1. So, year 2, 8. Year 1.57, 6, 5, and 4. Can you see that now? At year 0, our height is 4 feet. So, this is the answer. So that's how it is, guys. Initial value and rate of change. Initial value, again, let's review. Initial value is this one, the starting point. Rate of change is this. How much does it change for every unit? Okay? So remember that. Those are the two vocabularies that you will continue to practice on in your next classes. Good luck.